All right, we're going to be starting our first lesson on for our practice in problem solving. It'll be first thing says write the decimal as a fraction or a mixed number. So let's go ahead and start there. We know x is going to be the number itself, right? The number. So this is going to be 0.212121 and repeating. So if we multiply it to 100, that means the decimal moves over twice. So this is going to be 21.21. Now, we know to move it twice into the 100 because there's two numbers that are repeating. So if we really wanted to write this down as 2121, we could have also written down 0.21 repeating, okay? And there's two numbers that are repeating, so there'd be two zeros. All right, now we minus one of them. So that means we're going to have this number here, the number we created, 21.21, repeating, minus the number that we have here, x. X is 0.21, repeating. Now, if we do that, we know that we're going to be minusing this 0.21 and 0.21, and that's going to just leave us 21. Now, we have to divide the 99 away from x, which would make 21 over 99. By the way, I can see that these are both divisible by 3. If I divide 21 by 3, that'll give me 7. And if I divide 99 by 3, that's going to give me 33. So that tells me that this is equal to either one of these numbers, which would be 21 over 99, but more specifically, if we were looking for a reduced number, we would put 7 over 33. All right, number 8 is for you to do. I'm doing all the odd ones to show you what to do. You'll do the ones over here, the even ones. Number 9 says, write the number shown on the scale as a fraction. If we start with 0.2 and then 3 repeating, remember that we're going to be multiplying this. First, we're signing x is equal to 0.2, 3 repeating. Since it's only one number that's repeating, we're going to multiply it to the power of 10 to the first power. So this would become 2.3 repeating. And now we will divide, or we're going to minus x from it. So we're taking 10x, minusing x. And that's going to be equal to 2.3 repeating. Let's see, minusing, remember what we said over here, 0.23 repeating. Okay. Let's see what happens when we do that. If I got 2.33 minus 0.23. Well, all the 3 repeatings are going to be done away with. So this will turn to 1. This will turn to 2. So I'll have 2.1. So now I know that 9x is going to be equal to 22.1, excuse me. All right. So we got rid of one of the x's up there, which made it 9x. And we got rid of one of the x's here. the 0.23 repeating. Now we have to divide 9 away, which means we'll divide 9 from the other side. 2.1 divided by 9. Well, we know we're going to have to move this decimal over here, which means we're going to have to go ahead and add a 0 over here. So let's see, x is going to be equal to 21 over 90. Okay. I probably should have made that a little neater. All right, and both of these are divisible by 3. 21 divided by 3 is 7, and 90 divided by 3 is 30. So this one should be 7 over 30, if I did this correctly. Okay, and next we're coming down to do number 11, right? 0.87 repeating as a fraction. This line's over both of them. So if we do this, we know that x is going to be equal to 0.87 repeating. We have 2 of them that were covered, so we'll be multiplying this to 10 to the second power, which is 100x. And that'll give us 87.87 repeating. We're going to minus an x from here, so this would be 100x minus x. Remember that x was 0.87, so this is going to be 87.87 repeating minus 0.87 repeating. That's going to leave us 87. So this would be 99x is equal to 87. We divide 99 away to get x by itself. So we divide 99 over here. Our answer is 87 over 99. I think that's as much as we're going to be able to reduce it unless I can come up with some number that is divisible to both of them. The only number I can think that even might do that might be 3. I'm not even sure about that. We're going to try 87 divided by 3. The reason I'm using 3 is because I know 99 is one of those numbers that's either going to be divisible by 9 or 3 or 11. I'm going to go with 3, the smallest number first, because I know 87 isn't divisible by 11. That would have to be 88. See, 3 goes into 8 2 times. Give me 6. And leave me 20. Hey, that does work out. Because 27 divided by 3 is 9. So I make 29. So this could also be x is equal to 29 over, well, 99 divided by 3 would be 33. All right, let's try number 13. Write 1.48 repeating as a mixed number. Wow. Not giving us a lot of room to work over there, so I'm going to put it over here for now, just for us to work out the problem. You could put it wherever you're going to work it. Let's see, so x equals 1.48 repeating. That means I'll need 100x. Again, since 2 of my numbers are repeating, I need 2 zeros there, which will turn this into, let's see, 1 point, well, that's moving it, will actually be 148 point, let's see, 48 repeating. And then we have to minus 1, right? So it's 100 minus 100x minus x. Because that's going to be equal to 148.48 repeating minus, and we said x was 1.48 repeating. Well, the 48s get out of the way, so that leaves me with 148 minus 1. That's pretty easy math. That leaves me 99x over here equals 148 minus 1. That's 147. All right, now let's see. I got to divide by 99 to get x by itself. And 147 divided by 9. Well, I know 99 goes into 147 at least one time with 48 left over. So this is really going to be 1 and 48 over 99. Is there a number that goes into 48 and 99? I think yes. I think 48 is divisible by 3. And if I do that, that's 1, giving me 18 left over. That's 6, so that's 16. So it could also be 1 and 16 over, 33, because 99 divided by 3 is 33. So this one would be 1 and 16 over 33. Or if they left it as a big number, I guess it could have been 1 and 48 over 99. All right, and remember this wasn't for number 12, so please don't use it for number 12. We were doing number 13, just needed some room to do it. And now we're going to go to number 15. It says a manufacturer determines that the cost of making a computer is 2.16 repeating, right? The cost as a fraction, as a mixed number, okay. Right, the cost as a fraction and a mixed number, okay. So once again, I'm going to try to take a shortcut here. We already know what x is, which means if 1/6 is repeating, we're going to multiply this by 100x. That's going to be equal to, 2 over 2, 1/6, 0.16 repeating. And once we got that, we'll be minusing x from it. So this is going to be 2.16, and we're going to be minusing what we said x was, and x, of course, is 2.16. So it's minus 2.16 repeating. That's going to put us at 214. And that has to equal 99x. If we do this, now our fraction has to be 214 dividing that by 99, so we'll be dividing this side by 99. That is our fraction. Now they're saying a mixed number. Well, this mixed number comes from 214 being divided by 99. And I'm pretty sure let's see, 214 divided by 99. Well, I know it's going to go into it twice because that's at least 200 in there. So it's going to be 2. And what's left over? Well, 99 is almost 100, right? So if this was times 2, it would be 200, but it's not. It's minusing 2 of them, so that's going to be 198. And that's going to give me a 6. Got to borrow 1, 9, 10, 26? Yeah. So 2 and 26 over 99. And I'm pretty sure, unless I could reduce that, that's the end of that problem. And I have to say, I do see one little error. I mean, I forgot over here, this isn't going to be a 2 after all. Let me see here. So I'm looking at this. I realized I had to borrow 1 from here and here. So this is going to turn this one into a 1. This is going to turn this one into a 10. This is going to turn this one to a 14. This is actually going to be 16. That's going to change my answer just a wee bit to 16 instead. I still don't think there's a way to reduce it. No, I don't believe there is. So that would be 2 and 16 over 99. All right, we have this last one here, number 17, higher order thinking. When writing a repeating decimal as a fraction, why does the fraction always have a 9s or 9s and 0s as digits in the denominator? Okay, wow. All right, let's think about this. And I hope you don't mind that I did this, but for the sake of me having to type a lot, I'm just going to take the answer and paste it in here. Let's see, and that is that you always subtract x from an equivalent expression whose constant is a power of 10 and end with a constant of x. That is 9 or 99 or 999 and so on. Then you divide by that constant to solve for x. The reason that there's zeros there is sometimes you're going to have to go ahead and move that decimal places, right? Because you're taking that number on top that's a decimal and turning it into an integer, okay? And we'll write that in here. Smaller letters, hopefully. The zeros come from turning decimals in our fractions to integers. And really, it's come from making equivalent fractions by turning decimals in our fractions to integers. Okay, and that would be the correct answer for this one here. All right, and that is the end of our homework today. See you in class. We'll be grading. And hope you have a great night.